Welcome to part 1 of 5 of the Agentic AI Foundations immersive training. This module, Introduction to Agentic AI, is the first of 4 that will take us from understanding chatbots to mastering autonomous agents. This video will cover 4 main areas. We'll start with an introduction to Agentic AI, covering evolution, examples, and trends. Then, we will dive into LLM Fundamentals. Next is AI Agent Architecture, followed by Environment Setup. Module 1 is the Introduction to Agentic AI. We'll explore what it is, its origins, where it's headed, and look at real-world examples across different industries. Agentic AI is an AI system that perceives its environment, makes autonomous decisions, takes goal-directed actions, adapts based on outcomes, and operates across multiple steps. Think of it as a goal-driven, tool-using, multi-step, and self-correcting system. The evolution of AI has progressed from reactive chatbots like Siri and Alexa to assistive copilots like ChatGPT. We are now entering the era of autonomous agents that can handle complex workflows, and in the future, multi-agents will collaborate on human-level tasks. Agentic AI differs significantly from traditional AI. Agents handle multi-step, open-ended goals, interact in a continuous loop with the environment, use long-term memory, access external tools, and can self-correct, aiming for semi to fully autonomous operation. We see agent examples across many industries. Devin excels in software development. AutoGen allows multi-agent collaboration for data analysis. Perplexity AI is a powerful research tool. Intercom Fin manages customer support. Glass AI assists in healthcare, and Claude Code is used for DevOps and infrastructure. Looking ahead, single agents will handle complete projects by 2024. Multi-agent enterprises will automate entire departments in 2025. By 2026, we'll see agent-to-agent economies. Beyond 2027, the focus shifts to recursive self-improvement and human-AI co-governance. Module 2 focuses on LLM Fundamentals. We will discuss tokens, embeddings, context windows, and prompt engineering, the intelligence engine powering every AI agent. Large language models process information in a pipeline. Input text is tokenized, processed by the transformer using multi-head attention, and generates an output. These models are scaled, trained on massive data, fine-tuned to align with human preferences, and use autoregressive inference to predict the next token. Tokens are how LLMs see language, often representing parts of words. The context window defines the maximum number of tokens an LLM can process. Embeddings convert words into numerical vectors, capturing semantic meaning for advanced functions like memory retrieval and context-aware reasoning. Prompt engineering includes several techniques. Zero shot is for simple tasks without examples. Few shot uses a few examples to guide the model. Chain of thought forces explicit reasoning. System prompts set the agent's persona and constraints. The ReAct pattern is crucial for agents, using a reason, act, and observe loop. Standard models are faster and cheaper, ideal for basic tasks. Reasoning models are slower and more costly but excel at internal chain of thought, complex planning, math, and formal logic. Use standard models for default tasks, and switch to reasoning models for planning and code review. LLMs have limitations. Hallucinations can be fixed with retrieval augmented generation. Knowledge cutoff is resolved by giving agents web search tools. Context limits can be overcome by chunking and vector search. Math and reasoning struggles are addressed by giving agents Python execution or calculator tools. Module 3 delves into AI agent architecture. We will explore memory systems, planning, tool use, and the ReAct loop. This module explains how agents think, remember, and act autonomously. The AI agent architecture centers on the LLM brain for core reasoning. It uses perception for input and memory for context. Planning breaks goals into steps. Execution takes action. Tools extend capabilities, and reflection evaluates outcomes for self-correction. Agents use 4 memory types: in context, working memory, instant speed; external, long-term vector DBs; episodic, past interactions, learning from experience; and procedural, skills embedded in model weights, 0 speed. The ReAct loop is fundamental to agentic planning, running in cycles: task, thought, action, and observation. Other strategies include tree of thought, which explores multiple paths, and plan and execute, which creates a complete plan before acting. Tools extend agent capabilities. These include information tools like web search, computation tools for running code and math, storage and files for I/O and databases, and external APIs for integration with services like GitHub or Stripe. Tool calls are structured requests injected into the context. This is a 6-step process for a complex task: plan, search, extract, compare, write, and verify. Each step uses LLM reasoning or specific tools, demonstrating how agents break down complex goals into a structured, executable workflow. Module 4 will focus on environment setup, establishing your professional AI development workspace. We will cover Python, VS Code, API keys, and making your first calls to the OpenAI API. To set up your Python environment, first, install Python 3.11+. Second, create a virtual environment to isolate your project. Third, install the core agent libraries, including OpenAI, LangChain, and AgentOps for observability. Configure your IDE with essential extensions like Python, Pylons, and GitHub Copilot. A recommended settings.json file ensures your virtual environment is selected, and your files are automatically formatted and saved for a smooth development process. Security is crucial when handling API keys. Use the .env file pattern to store keys and load them using Python's .env library. Never hardcode keys or commit the .env file to Git. Remember to rotate your keys and set spending limits. The OpenAI API allows basic chat completion with a list of system and user messages. Function calling enables tool use by providing the model with tool descriptions. Key parameters like temperature and max tokens control the output's creativity, length, and cost. A recommended project structure organizes your agent code and tools logically. For local LLM development, tools like Ollama, LM Studio, and Jan.a allow you to run powerful open-source models for free. AgentOps can be used for debugging and observability. In summary, we covered the evolution and components of agentic AI, LLM fundamentals, the agent architecture, including the ReAct loop, and set up your Python development environment securely. We've laid the groundwork for building autonomous agents. Thank you for completing Part 1, Agentic AI Foundations. You now have the fundamental knowledge needed for the next steps. We invite you to watch Part 2, Building Your First AI Agent, where we dive into frameworks like LangChain and Crew AI.